So now we're going to talk about the biconditional of P and Q. So this is the statement P if and only if Q. So the way it's denoted is with a double arrow. So it's going to be true if both statements have the same truth value. So if they're both true or they're both false, and it's false if they have opposite truth values. So I did want to mention too that if and only if often gets abbreviated as IFF. Okay, so if you see IFF, it means if and only if. So let's look at the truth table for this biconditional statement. Right, my truth table has 4 rows in it. And remember, they have to have the same truth value to be true. So the first row, it would be true. The second 2 rows, they have opposite truth values, so false, false. And then the last one, they're both false, so it would be true. So this is the truth table for our biconditional statement. Now in terms of our operations, order of operations, let me mention we've added in a new symbol. So let's talk about the order of operations. So remember that not is done first, that negation, the tilde is done first, ands or ors are done second, and then arrows like if or if and only if are done last. So really what's going on with an if and only if statement, a biconditional statement, it's saying both if P then Q and if Q then P. So really what I'm trying to say is that this biconditional statement, it's logically equivalent to if P then Q and if Q then P. And we can show this is true through a truth table, right? If I want to show that they're logically equivalent, I could show that they have identical columns. So again, I still have 4 rows. If P then Q, Q then P. So here you get true, false, true, 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 false, true. If P then Q and if Q then P. So look at the last 2 columns and put an and between them. True, false, false, true. And this was the same as our biconditional column. So these are in fact logically equivalent. So let's use this fact. We want to rewrite the following statement. As a conjunction. Remember that conjunction means and of 2 if-then statements. So we want to rewrite this statement. The computer program is correct if and only if it produces correct answers for all possible sets of input data. So let's look at our two statements that are here within this if and only if. The computer program is correct if and only if it produces correct answers. So this would be like our P, this would be like our Q. So then I'm going to write if P then Q, if the computer program is correct, then it produces correct answers for all possible sets of input data. And so here's our conjunction. And now you're going to write the converse of this statement. If Q, then P. And if this program produces the correct answers for all possible sets of input data, then it is correct. So again, it's a conjunction of two if-then statements. So this would be my answer right here.